Good day, everybody. The 10 people that are left. Okay. Where's Dirk now? Mr. Van Dijk. He's gone to the bathroom, okay. Because I was about to say, my oh my. I think I'm speaking from the other side, the other perspective, where we actually think that at this stage we have to intervene much earlier in the FET phase of schools. So my talk today will be basically on a strategic technology catalyst for community intervention, and specifically in schools. It's based on research that we've done currently in the southern Gauteng area. So I'm not going to spend too much time on, I think everybody around here knows the fourth industrial revolution and everything surrounding it. So I presume I'm not going to have to go into much detail. To give a quick background on the idea to product, it's a laboratory that was developed in 2011 to alleviate poverty in the southern Gauteng area. It was created by Professor Dion de Beer, and the whole idea behind it was to move from an idea to prototype to an actual tangible product. So that's where everything started off, and it has developed now into various different models, and that's what we're trying to do at this stage. We're trying to see what can we do with the existing rather than trying to reinvent the wheel or trying to come in with something completely different or new, such as the previous speaker. So that's what I'm saying, my, okay, and all these people have these interesting slides, these beautiful slides, and I'm coming with clip art. You can see I'm a real old teacher. Okay, any success? There we go. Okay, so like I said, I'm not going to go into too much detail about the background of AM or even the fourth industrial revolution in South Africa. I'm merely going to state that, in summary, for the perspective from where we are coming from, AM at this stage is a disruptive innovation system that is key to change in South Africa. That's very important. I loved your talk. After this, you're either going to love me or you're going to hate me. I hope it's the first one. According to the latest Wallace reports, there's an annual influx of about 6,000 printers, desktop printers annually, and about 90% of those are used for educational purposes. But the biggest conundrum that we're sitting with at this stage is we have injection of funding happening in the education system, but not reskilling or upskilling, and that's a major problem. So one of the ways to address is on that level here, but I said to them while you were away now, there's a much earlier introduction that we feel that can actually make a big difference in the system. So at this stage we've received funds from various government bodies, including TIA, and now it's called the DSI, not DST, am I right? Yeah. Okay. Under the CPAM project, the Collaborative Program for Additive Manufacturing. And the problem that we find at this stage, that's especially coming out in the white paper, is that there's very little documented research done on pedagogical development or curricular development for these systems. And I'm not going to go into the background really. All I wanted to say here, with the technological revolution, such as the fourth industrial revolution, we expect to see a lot of disruption in all sectors, including the education sector, obviously. So our need has changed. We're moving from industrial technology transfer that we used to do. So you had to explain to sectors, private sectors, communities, individual parties, what is additive manufacturing. That has changed now. A lot of the industries have adopted AM into their system, but now, what do we sit with? We're sitting with a lack of skills to operate these emerging technologies as a drive towards fourth industrial revolution. Now I'm stating that specifically, so I'm not saying there's a lack of skills necessarily for the technology. People have the skills to operate a 3D printer, for example, but how do you use that skill to ready us for the fourth industrial revolution? That's where the big problem is. And then I use the example by saying that the quality depends on the skill, expertise of the operator rather than the technology that's used. I mean, you can have the best technology, but if you don't know what to do with it, and although there's a rapid growth in this disruptive innovation system, there's a lack of skills expert due to three things mainly for us, and it's no systematic educational platforms, very little comprehensive training, and very little certified programs that are actually, so it's our first idea to product model was based on that open source idea. I'll get to that in a second, and it's wonderful for what it was, but it was just tech transfer. It didn't create a platform or system to re-skill people actually at the end of the day. So what's important for me and for what we do in the idea to product is we need sustainable development to take place. It's not just to go in, throw money or throw stuff at people and say, here's a new technology, this is what you do, you press play, or you press print, and there it is, you're done, you've made something. But what do we need to do is we need to change the educational system. We need to actually look at how it affects the system, where curriculums need to be updated to respond to the needs of the fourth industrial revolution. But the biggest problem that we found at this stage is for some or other reason, the uptake is very slow. So that's my funny little turtle, my little anecdotal, Okay, I see everybody smiling. Okay, that's good. Everybody got it.
There's no snail available.
Yeah, exactly. Okay, so furthermore, when investigating the revised national curriculum statement, the CAPS documents, everything that we find in the FET phase, it becomes very, very, very clear that there are a lack of reskilling taking place in that ambit. And we decided to go and investigate and see why is it taking place in the classroom. And it became apparent that it's being ignored for a couple of reasons. The first of these would be funding, obviously. A lot of the schools, like you said earlier, you're sitting with broken windows. I've been in schools where there are no desks. How do you transfer this knowledge without even basic necessities like running water? The second one would be the actual time constraints, not just for introducing new, but the current system, the current curriculum system that's used for subjects like design and technology and engineering, graphics and design in the FET phase is so restricted that they actually have to use extracurricular hours to catch up on their subjects. So how do you introduce a new knowledge or a new leg into this to ready these people? The next one would be outdated assessment standards and assessment methods, because you're not assessing the same technology. So sometimes they would introduce, like, I know for the last 10 plus years they've had AutoCAD as a CAD package, and the government, I actually think it was the Western Cape that started with it, had all these workshops, and then it just dwindled off, and there was no throughput of what's going to happen after they've introduced the CAD. And it ended up with somebody that got his diploma degree about 40 years ago not being competent in CAD. And the biggest mistake, in my opinion, that happened was, from the educational point of view, was that the introduction of CAD into technology subjects was an optional extra. So what ended up happening was the educators didn't have a choice in the matter to say, do we want to be upskilled or not? They were basically just given a choice of, you can, if you want to, introduce this into the classroom, or you can choose something else. And I experienced it firsthand when I was still an educator. The next was obviously overworked and underpaid educators. That has a big influence on it. So there's a lack of interest, and we have to go back and see, where did they lose the passion? Where did they get so afraid of new technology? And then the last one was obviously then skills. Now, to address these limitations, the following were looked at. We looked at the overall picture, as I said yesterday, the roadmap to AM in South Africa. And we decided pre-university education systems are the best suggestion to focus on. The reason being, there's a lot of things taking place at university level. Okay, a lot of talk, a lot of hype, a lot of experimenting, a lot of research. But everything that's happening inside the schools are usually extracurricular, moved to workshops outside of the classroom environment. And if it is introduced into the classroom environment, it's usually through workshops taking place, through science weeks, stuff like that. It's not integrated into the actual system. So we investigated the revised curriculum statement, the CAPS documents, and we found then that these open source maker platforms and workshops were taking place outside, but not in. And I wanted to keep on going back to that. And then we found that there were limitations in the content and the geographical environment that the training were actually taking place. And needs addressed could take place through these programs that we were developing. Okay, so we could actually come up with a solution. So just to give you an idea, I'm deviating slightly, just to give you an idea of the two main streams that we have of the idea to product at the moment. On the left, you'll see the tech transfer model, or what we used to call the open source model. It was based at academic locations. You train from an idea to a product. It's open source software. It's government funded. The program is very adaptable to whether it's at an exhibition or whether it's at a school taking place or whether somebody comes into one of our laboratories. And the two limitations that I found was, one, it's limited to the general public exposure. The model worked wonderful because we had it at different universities, okay? But your general public out there don't necessarily get the exposure. They don't know about these laboratories. It worked for us at that stage because we needed the funding. So where do we get the funding? We do the research for government and we feed back. So we could train people for free. So that model worked for what it was good for, but it ended up more focusing on tech transfer and not reskilling people. I would say there's about between a 10 to 20% feedback of people that really ended up designing prototypes out of going through the process. So it worked to transfer the knowledge, but it didn't reskill them so that they could understand what was actually going on. And the training was very basic, without formal assessment criteria. So it ended up not having them to rethink, and where do they learn? By making mistakes. And there we will agree, definitely, that you have to put back the power back into the students' hands, the learners' hands. And I will explain that later. Then there's a new model, the accredited model, and it's based anywhere that you have site verification and workplace approval through the CETAs. This one is due to the fact that we got the funding for developing that program through MERCETA. So it's kind of working for us. That's what I'm saying. I hope we still love each other after this conversation. Open or proprietary software, privately or government funded. It's accredited. We train operators and we train facilitators. So they walk away with a short learning program qualification. But the second one, the facilitator or the trainer model, was developed so that people can not only train to become an operator, but know how to use the technology to actually train other people. And from that, we can generate, or that person can generate revenue again, create a new business model. The service centers that are opened at this stage aim to incubate. So all of them are going to become self-sustained incubation systems, and the only negative drawback is it's time consuming, and that's due to our CETAs, and I'll close that topic right there. It's just time consuming. I'm going to quickly deviate again and just show some highlights from the past year. We did a lot of training. I'm not going to go into detail. This was training for the Minister of Telecommunications. That was adults and staff members and their children, various educator training programs, and then we've got our outreach programs where we literally, from exhibitions right through to science weeks, right through to private interventions at schools, have gone around and literally worked on ground zero. So it's very real, and we're having a lot of fun. And It's amazing. My concluding slide is one of my highlights for the year, and I'll share it with everybody just now. This last picture that I showed now, that's actually students, engineering students, mechanical engineering students that are busy working on a project. To give everybody an idea, that's a Sunday evening at just after 11 at night that picture was taken. So the process is working well enough for them to want to be there even over weekends. Okay, so the research methodology is an interventionist research concept that's based on pragmatic functionalism. So we identified the limitations, and then what we did was we collaborated with the Department of Education to identify actual educators. And what I did was we decided to get their backing and then strategize how can we intervene into the actual educational system to do this experiment. And we investigated the current models, and we constructed a pilot program. And that pilot program was based on the concept of what we call LTSMs, Learner Teacher Support Material. And I'll explain just now why it's gone in that direction. We trained the pilot program to the educators over a period of 2 years, various workshops, until we felt that they were completely competent, and we dealt with every facet that we could possibly think. So the turnaround time normally now is not 2 years. It's just we try to go in on every angle to make sure that we cover all bases. Continuously we did observations, surveys, interviews during these workshops where they could really express themselves, to really see what do they fear, what's going on in their minds as educators currently in the system. Then we assessed the pilot program, did the observations and surveys after we concluded all of that, and then we constructed a learner program. Now we are pleased to say that the schools that partook are now into the next phase, where they are introducing each their own system into their classrooms. And we are going into the next phase. Now this is underpinned by certain educational foundations. The first one would be, and all of them are current systems from across the globe at the moment. The first one would be Blickstein. Now Blickstein works on the 3 pillars of technology, the experiential learning, constructionism, and critical thinking. And that's where I was saying earlier, it's crucial, especially for experiential learning, that learners, school learners, go through the process, the reiterations, to continuously make mistakes and realizing you have to start thinking out of the box. And the moment you start doing that, it becomes quite interesting. The second one would be Werner's CDIO. Construct, what was the second one? Design, implement, and I think the last one is operate. Yeah. And then it's Kolb's experiential learning. We did a lot of work through Kolb's experiential learning. And then Shelley through open source versus proprietary software, and then collaborative work. And all of this is underpinned under the conceptual framework of the TPAC model. And very few people actually know about the TPAC model. The TPAC model is specifically for technology education. And at this stage, can I just quickly have a show of hands of people that actually know about this model? That's my point. And it deals with it. If you look at the 3 spheres, technological knowledge, content knowledge, and pedagogical knowledge. And when the 3 of them merge together, you get the technological, pedagogical, content knowledge, which is exactly what we are trying to achieve. We work similar, but from different perspectives, if that makes sense. Okay. And the model, or flowchart model that I work on, or knowledge flow model, looks roughly like that. So that's, I'm not going to bore everybody with everything, but if you look on the right bottom side, you'll see where the schools are. Now, why we started doing this is we set at the center, it's a hub and spoke model, but the idea was the hub is the idea to product. It's right in the middle, and all the education systems can be fed into around it. So you'll see on the bottom right, there are schools, but now what happens with a school learner when they are done? They've got 3 options. They either go to TVETs, or they go to universities or universities of technology, or they will go back into the community. So we had to address all 4 of them, And that's what we're busy doing. We are intervening with idea to product laboratories in all 4 of those sectors so that we can feed on both sides. So what we're trying to do is we're trying to reskill educators so that they can take the new influx of students when they finish school, but also educators in the school itself, so they know what to do. So we're trying to narrow that gap that's actually existing at this very stage. So I'm not going to go into a lot more detail there, but there's scope for wherever you're going to have that learner go. Whether they finish school or not, there is an exit so they can go to a community center or a lab at a university. Now, this first group of schools, if I can remember correctly, the Department of Education gave us 72 schools from which to choose and to interact and see if they're interested. From the 72, there were about 30. Yeah, it's about 30 of them that said that they want to partake, and then life happens. Whatever happened with a person happened, and at the end of the day we had 16 people that actually partook. Now these 16 people are from 16 different schools, or from 11 different schools. So some of them are more than one educator, and some of them are in the STEAM band. So they're not necessarily technology educators, they can be science or mathematic educators, or whatever the case might be. So we had 2 areas that we focus on. It was the West Rand and then the Southern Gauteng, or the Vaal Triangle, right at the bottom. At the top it was 2 schools. I'm not going to go into names. If anybody wants any further details, I'll give it to you afterwards. And then we had 9 more schools in the Vaal Triangle area. Okay. All 11 of these schools have completed the first phase and are implementing with printers in their schools at this stage. In the future, or the next phase that will happen from January, the next 11 schools have been identified. So that covers roughly the East and West Rand and the Southern Gauteng areas, which I think is quite a feat if you think our laboratory consists of 4 people running this. So it's if we didn't have this mechanism and the support of the actual educators, it wouldn't have happened. It's as easy as that. Then I've got some results from the actual research and from the actual surveys, just to give an idea what the educators felt. So, what have you learned by attending 3D printing pilot workshops at VUT? And most felt that the operations and practice was the thing that they focused on the most. But that's also kind of biased because that's what we were focusing on. The thing that bothered us is using 3D printing as an LTSM in classrooms was a completely foreign idea for educators. They don't feel that they can actually introduce it as a support system into the classroom. So it's all of these stigmas that we have to try and break down that are currently happening in the classroom. Standard operating procedures, how to create an STL, 7%. Then classroom practice and safe operating procedures was 13%. Troubleshooting, 20%. How to create a scan, create CAD drawings, and then maintenance. So those 2 at the opposite ends was the most important for me. The next one, would you be able to use what you've learned? And 93% said yes. How will you use what you've learned? And this is where it becomes contradictory for me, because 60% of them said they can use it as an LTSM, but that's that insecurity that keeps on creeping back, whether they can introduce it. And I'll link it now to what the reason is. It's actually time. They're afraid of time constraints. That's actually what it is about. But 60% of them said that kinesthetic LTSMs, physical, tangible interaction with objects is a quicker way to learn. I'll give an example. Not all learners are good with spatial perception when the brain doesn't focus on it. So you'll have a math student and they will, for example, not be able to tell you when they have to think of a certain object, all the sides. But when they have the physical object, it's easier to observe and it's easier to absorb the knowledge because it's more than one sense that they're actually absorbing. Next, would digital fabrication benefit STEM education? And there was a purpose why we left out art in this in the beginning, we wanted to first work on the creative aspect in the technical fields, if that makes sense. Because the moment you start going into art, there's other ideologies that become a reality, theories behind how things are interpreted. And so we wanted to keep it, more empirical at this stage. And again, 93% said yes. Should the current curriculum be updated? 93% said yes. Is the current curriculum overburdened? 60% said yes. Is there enough time to introduce new skills in the classroom? And this is where it becomes interesting. Only 20% said that there's not enough time. 13% felt that they were confident enough to make time in the classroom to work with this technology. The rest were undecided due to these fears that they do not know, can they or can't they. Should only educators or learners use 3D printing? And yeah, it became more evident. More than half of the educators felt that they should actually be in control of the situation and not the learners. But this is now critical when you're thinking of the disruptive innovation trend. It's not a linear trend. You're not going to have a to B linear development. You've got that exponential that's going to go past, and they don't understand that certain time constraints will fall away when you're working with these objects, because things that used to take 10 minutes to explain in the classroom, you can do with one object now in 2 seconds. So the system needs to change, like we said earlier. Okay, how will learners be influenced by introducing digital fabrication in the classroom? Increase their performance, and then enhance understanding, improve learning interest, benefit sensory kinesthetic systems. That was 20%. Benefit their drawing skills, and about 7% felt it would enhance concentration in the classroom. Should open source CAD or proprietary CAD? And this one was, I really don't understand it, because you're sitting in a township school where they don't have desks, and they said they would prefer proprietary CAD software. And I felt to myself, no, okay, something just broke. I don't really get what happened here. And it actually came out, it's due to the last 10 years plus, where government had given proprietary software such as AutoCAD to the schools. So they're used to the fact that the government is telling them, please use this. But there's not enough upskilling and reskilling taking place. So that's why that little error popped up in the research. What would the educators like to experience in follow-up workshop? And again, most of them felt more practical work. Most of them want to get more experience. And then what constraints can influence the successful implementation of digital fabrication in the classroom? Just over half felt that just under half felt that it would be time consuming. A small margin of them felt that the technology can fail due to their own experiences during these workshops. And again, almost half of the people were completely uncertain. So that, again, it shows very clearly where the thinking pattern is at this stage. Then in conclusion, we can say that it's very apparent that LTSM system program will be able to infiltrate curriculum. And there's a reluctancy to accept the change that needs to take place at this stage, but it's not impossible. We just have to break that uncertainty by reskilling people. And then the DSI objectives, 2/3 of it, of the current objectives in the white paper can be met through this system. So on a grassroots level, right on the ground, we can make a humongous difference. And the recommendations, more funding and collaboration. That's definitely something that I feel, breaking down barriers, breaking down the boundaries, more businesses, more industry, and not just through CETAs. We have to have more and more collaborations, more formal pedagogical models have to be developed through the TPAC model. I think that is a critical idea, because you've got 3 facets and everybody is an expert in their field, but when that cross-pollination starts taking place, then there will be a massive start of development that will ready learners to get to that place where they need to go to university, and they will understand not just that a 3D printer is can I say, a tool for additive manufacturing, but it's a tool like a normal tool, like a hammer, like a drill, and you have to use it for the right application. And the biggest thing for me is we need to reskill people and move away from what Pablo Blickstein calls the keychain syndrome. They did an experiment with, I think it was about 30 schools in America. And every time they introduced 3D printers, like we do with tech transfer, we put a 3D printer down, we show people, look at the little picture, and we print this amazing thing, and they go, wow, okay, I can do this. But now what? They're saying basically that at the end of the day, we ended up with people that think that they can mass produce for their friends, little keychains. And that's all that they're thinking of the technology is at this stage. It's not only something that you can actually use now to move towards the fourth industrial revolution readiness in South Africa, but it's just something that they wanted to play with. And then lastly, curriculum reform, especially for assessment, so that we can have formalized ways, and especially when we look at industry, what are the outputs? What do we want to achieve with this technology? Where are we going? We need to look at the objectives, and we need to look at the curriculum and say, how can we superimpose the objectives of both on top of each other so that we can all get to the same place at the end of the day. And then I just want to leave you with this last thought. If we teach today's students as we taught yesterday's, we rob them of our tomorrow. And that boy's expression says it all, in my viewpoint. And that's it. Thank you very much.